Next chapter, binomial expansions. Now, a binomial is an algebraic expression with two terms. For example, x plus 2 has two terms, x and plus 2. 2x minus 4 has two terms, 2x and minus 4. Previously in Form 2, we learned how to multiply binomial expansions. For example, x plus 2 times 2x minus 4. Every term in the first bracket is multiplied by every term in the second bracket. And so we shall have x times 2x minus 4, then plus 2 times 2x minus 4. X times 2x is 2x squared. X times minus 4 is minus 4x. 2 times 2x is equal to 4x. 2 times minus 4 is minus 8. And if we simplify, we shall have 2x squared minus 8. We also learned that x minus 2 squared means x minus 2 times x minus 2. And so we multiply like we've done. That is x times x minus 2. And then minus 2 times x minus 2. X times x is x squared. X times minus 2 is minus 2x. Minus 2 times x is minus 2x. That's 4. And so we simplify and get x squared minus 4x plus 4. The opening of brackets in an expression is called expansion. Suppose now we had 2x plus 1 raised to power 3. This means 2x plus 1 times 2x plus 1 times 2x plus 1. We expand the first two brackets. 2x plus 1 times 2x plus 1. And we have 2x times 2x plus 1, then plus 1 times 2x plus 1. 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. And 1 times 1 is plus 1. And we shall have 4x squared plus 4x plus 1. Now we multiply this result with the last bracket. That is 4x squared plus 4x plus 1 times 2x plus 1. It's simple to multiply the second bracket with the first one. So we shall have 2x times 4x squared plus 4x plus 1, then plus 1 times 4x squared plus 4x plus 1. 2x times 4x squared is 8x cubed. 2x times 4x is 8x squared. 2x times 1 is 2x. 1 times 4x squared is 4x squared. 1 times 4x is 4x, and 1 times 1 is 1. And if we simplify, we shall have 8x cubed plus 12x squared plus 6x plus 1. And so as the power gets higher and higher, the expansion becomes more and more tedious and prone to errors. The Pascal triangle gives the coefficient of the terms in a binomial expansion. Consider a binomial expansion of the form a plus b raised to power n. This has two terms, a and b. When this binomial is expanded, the coefficients of the products starting from left to right are shown on this Pascal triangle. When expanding, the power of a decreases as that of b increases as we move from left to right. For instance, if a is raised to the power of n, b will be raised to the power of 0. And so we shall have a raised to n times b raised to 0. And then a raised to power n minus 1, the power is reducing, times b raised to the power of 1. And then a raised to the power of n minus 2 times b raised to the power of 2, and so on and so on. Remember to put the coefficients in front of the terms as you multiply. For example, Consider a plus b raised to the power of 4. Here, n is equal to 4, and from the Pascal triangle, the coefficients are 1, 4, 6, 4, and 1. We expand. First terms, the coefficient is 1. So we have 1 times a will be raised to the power of 4, and b will be raised to the power of 0. So a raised to the power of 4 times b raised to the power of 0. Plus second terms, the coefficient will be 4. A will be raised to the power of 3 this time, times b will now be raised to the power of 1. Notice the powers will add up to n. 3 plus 1 will be 4. Plus third terms, coefficient is 6 from the Pascal triangle. A will now be raised to the power of 2 times b will now be raised to the power of 2. Fourth terms, the coefficient is 4 times a will now be raised to the power of 1 times b raised to the power of 3. Finally, the last terms, coefficient is 1. A will be raised to the power of 0 times b will now be raised to the power of 4. Finish that and we shall have b raised to the power 0 is 1. 1 times a raised to the power of 4 times 1 is a raised to the power of 4. Plus 4 times a raised to the power of 3 times b. Plus 6a squared b squared plus 4a b cubed plus b raised to the power of 4. Let us try real numbers, and you have x minus 2 raised to the power of 5. N in this case is 5. From the Pascal triangle, coefficients are 1, 5, 10, 10, 5, and 1. First terms, the coefficient is 1 times x will be raised to the power of 5 times minus 2 raised to the power of 0. Plus second terms, the coefficient is 5 times x will be raised to the power of 4 times minus 2 will be raised to the power of 1. Third terms, coefficient is 10. X is raised to the power of 3 times minus 2 is raised to the power of 2. Plus, in the fourth terms, coefficient is 10 times x will now be raised to the power of 2 times minus 2 raised to the power of 3. In the fifth term, coefficient is 5 times x is raised to power 1 times minus 2 raised to the power of 4. In the last terms, coefficient is 1. X is raised to power 0 minus 2 is now raised to power 5. And so we shall have 1 times x raised to power 5 gives us x raised to power 5 because minus 2 raised to power 0 is 1. And so we have x raised to power 5 plus 5 times minus 2 raised to power 1 is minus 2. Then times x raised to power 4 is minus 2x raised to power 4 plus 10 times minus 2 squared is 4 times x raised to power 3 is 4x cubed plus 10 times minus 2 raised to power 3 is minus 8 times x squared is minus 8x squared plus 5 times minus 2 raised to power 4 is 16 times x is 16x plus x raised to 0 is 1 minus 2 raised to power 5 is minus 32. If we simplify that, we shall have x raised to power 5 minus 10x raised to power 4 plus 40x cubed minus 80x squared plus 80x minus 32. And that is the expansion for x minus 2 raised to power 5. Another example, 2x plus 2 raised to power 4. This binomial expression has two terms, 2x and 2. N is 4 and the coefficients from the Pascal triangle are 1, 4, 6, 4 and 1. First terms, coefficient is 1, and so we have 1 times 2x will be raised to power 4, all of it, times 2 will be raised to power 0, plus second terms, coefficient is 4 times 2x raised to power 3 times 2 raised to power 1, plus the third terms, coefficient is 6 times 2x raised to power 2 plus 2 raised to power 2, plus the fourth terms, coefficient is 4 times 2x raised to power 1 times 2 raised to power 3. And finally, the last term, coefficient is 1. So we have 1 times 2x raised to power 0 times 2 raised to power 4. So we shall have 1 times 2x raised to power 4 is 16x raised to power 4. 2 raised to 0 is of course 1. Plus 4 times 2x raised to power 3 is 8x raised to power 3. And then times 2 gives us 16x raised to power 3. Plus 6 times 2x squared is 4x squared. 2 squared is 4. So 4x squared times 4 is 16x squared. Plus coefficient is 4 times 2x raised to power 1 is 2x. 2 raised to power 3 is 8. 8 times 2x is 16x. Plus 1 times 2x raised to power 0 is 1. 2 raised to power 4 is 16. And so we complete that and we shall get 16x raised to power 4 plus 64x cubed plus 96x squared plus 64x plus 16. And that is the expansion for 2x plus 2 raised to power 4. Next, applications of binomial expansions. Now, consider 1 plus x raised to power 5 and 1 plus 0.2 raised to power 5. We can use the expansion of 1 plus x raised to power 5 to solve for 1 plus 0.2 raised to power 5. First, we equate the corresponding terms. If 1 plus x raised to power 5 is equated to 1 plus 0.2 raised to power 5, then 1 is equal to 1 and x is equal to 0.2. We expand 1 plus x raised to power 5 and then substitute x for 0.2 and we shall get the answer. And so 1 plus x raised to power 5, n is 5 and therefore the coefficients are 1, 5, 10, 10, 5 and 1. Expanding, first terms, coefficient is 1 times, the first term is 1 will be raised to power 5 times x raised to power 0 plus second terms, the coefficient is 5 times 1 raised to power 4 times x raised to power 1, then plus 10 times 1 raised to power 3 times x raised to power 2, then plus 10 into 1 squared x raised to power 3, then plus 5 into 1 raised to power 1 times x raised to power 4, and finally 1 times 1 raised to power 0 times x raised to power 5. That gives us 1 raised to power 5 is 1, and then x raised to power 0 is also 1. So we have 1 times 1 times 1 giving us 1, then plus 1 raised to power 4 is 1. X raised to power 1 is still x, times 5 we get 5x, plus 1 raised to power 3 is 1, x squared, then times 10 will give us 10x squared, then plus 1 squared is 1 times x cubed is x cubed, times 10 will give us 10x cubed. Then plus 1 raised to power 1 is still 1. X raised to power 4 is x raised to power 4. Times 5 will give us 5x raised to power 4. And finally, 1 raised to power 0 is 1. X raised to power 5 is x raised to power 5. And then times 1 will give us x raised to power 5. We substitute for x in this expansion. We shall have 1 plus 5 into 0.2 plus 10 into 0.2 squared plus 10 into 0.2 cubed plus 5 into 0.2 raised to power 4 plus 0.2 raised to power 5. That gives us 1 plus 0.2 times 5 is 1. 10 times 0.2 raised to power 2 is 0.4 plus 0.08 plus 0.008 plus 0.00032, and that gives us 2.48832, and that is the answer for 1 plus 0.2 raised to power 5. And you can test that with the calculator. Now, notice that 1 plus 0.2 is equal to 1.2. So we would as well have had 1.2 raised to power 5. It's the same as 1 plus 0.2 raised to power 5. A typical exam question will look like this. Expand 1 plus x raised to power 5 to the third power of x, and hence solve 0.8 raised to power 5. Now, the third power of x means we expand up to where x is raised to a power of 3. How about 0.8? Is it related to 1 plus x? You can think of 0.8 as 1 minus 0.2. And so we relate 1 plus x raised to power 5 with 1 minus 0.2 raised to power 5. We expand and substitute x with minus 0.2. N is 5 and the coefficients are 1, 5, 10, 10, 5, 1. So we start 1 times 1 raised to power 5 times x raised to power 0 plus 5 times 1 raised to power 4 times x raised to power 1. We've done this before. Plus 10 times 1 raised to power 3 times x raised to power 2 plus 10 times 1 raised to power 2 times x raised to power 3. We stop there. We've already arrived at the third power of x. And so we have 1 plus 5x plus 10x squared plus 10x raised to power 3. We substitute 1 plus 5 times minus 0.2 plus 10 times minus 0.2 squared plus 10 times minus 0.2 raised to power 3. That will give us 1 minus 1 plus 0.4 minus 0.08, and that gives us 0.32.
The way we teach it in university and in high school as well, and colleges, is if you fall behind, you're in desperate trouble. That if you miss a class or miss an idea or don't do your homework, you go to the next class and the teacher assumes you know it, but it's like Greek to you. And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor.